Welcome back, my pre-calculites. This is Miss Cowan broadcasting live in Florissant, Missouri. We're going to head into the last section of this unit, which is solving inequalities algebraically and graphically. And the first thing we're going to do is algebraically. And you hopefully have seen these. Absolute value inequalities occur a lot of different places. Whenever you get a test back from the doctor, they usually look for if you have some type of virus, or if you are looking at your cholesterol levels or blood pressure. These things come up all the time. So inequalities are very applicable to real life. We're going to solve absolute value inequalities today and solve quadratic inequalities, which is really a lot of fun. And then tomorrow we'll get into the solving graphically. The first thing I want you to do is I want you to name 3 values of x that would make the following inequalities true. Absolute value of x is less than 2 and absolute value of x is greater than 2. Pause the video here, write down your responses because it's going to be key to how you understand these absolute values, and then we'll be right back. Okay, so hopefully you've had time to write down your answers. Now, you should have picked values such as -1, 0, 1, 1.999, because this is all numbers whose distance from 0 is smaller than 2. So numbers whose distance from 0 is smaller than 2, so it's limited. It can't be smaller than -2. For instance, the absolute value of -3 would not be less than 2. It has to fall between -2 and 2. All values of all numbers whose value is greater than 2, there's no limit. So you could pick 2.001, 800, -10, -2000. You want all numbers whose distance from 0 is bigger than 2. There's no limit. Now, going to the definition of absolute value, if x is positive, it stays the same. But when x is negative, it's the opposite. So, for example, absolute value of -2 would be +2. It would be the opposite of that. When we go to absolute value inequalities, I like to think or between. When you see this absolute value of something bigger than or equal to a given number, it's equivalent to x being less than or equal to its opposite, or greater than or equal to itself. So you split it apart. In other words, to drop these inequalities, you have to take 2 cases. Just like if it was an absolute value equation, you have to take a positive case and a negative case. When I see the greater than symbol, I think great or, you have to split it into 2. Take the negative and flip the sign. Just like when you multiply or divide by a negative, you flip that inequality sign. Absolute value of x less than or equal to a given number. Since it's less than, it's limited, and you got to think between. So x is between negative, like in this case, -2 and +2. So think between. So I always think less and, but I think, okay, less and, that's between 2 given values. All right, let's do some examples. Now, as you should recall from algebra, you have to get the absolute value by itself so that you can split it into 2 different inequalities, or say it's a combined inequality. This is a greater than symbol, so we're already thinking great or. The absolute value is already by itself, so in order to solve this, we're going to have to split it into 2x minus 5 less than -3. Look how I flipped that sign. Or 2x minus 5 is greater than 3. Then you just solve both of those inequalities and you'll get your solution set. So plus 5 on both sides, here and here, and then you divide by 2, so you get x is less than 1 or x is greater than 4. Since it's an or, when you do your number line, x less than 1 goes to the left, x greater than 4 goes to the right. Instead of the open circles, we use the parentheses for interval notation. So to write this in interval notation, you know this is going down to -infinity. This side is going up to +infinity. So you would have -infinity up to 1, not including 1 because it's strictly a less than symbol, union, open parenthesis, union, open parenthesis, 4 to +infinity. All right, and that's it. So this one, you can't drop those inequalities yet. You have to get the inequalities by itself. I see a -2, so I'm thinking, I might have to divide by -2. That's going to mean I'm going to flip this sign, so you already should be thinking about that kind of stuff. So first step is going to be to minus the 5 from both sides. -5 - 5, that gives you a -8. Then I'm going to divide by -2. When I do that, I usually circle that guy, but in this case I didn't. You go less than or equal to, because I divided by a negative. So I've got the absolute value of x plus 1 less than or equal to 4. So when I see less than, I think and between. So that's going to mean x plus 1 is between -4 and +4. If your teacher taught you in the past to split it into the and two different ones, that's fine. I just find combined inequalities are easier. When you're talking distance, this means between. So -1 on each end and in the middle, and so you'd end up with x being between -5 and 3, and you would graph it like a so. And I'm going to use the square brackets this time because it's less than or equal to, so it includes the -5 and 3 in my solution set. There's the answer in interval notation. I want you to try these two on your own, and actually I think that's enough for today. We're going to split it up into 2 parts so that you can look at the quadratic part separately. I'll see you later.